Okay, so a couple of reminders before we get started. Tomorrow we're going to talk about the transformations of parent functions. It is something that you have done a little bit in an Algebra 2 class, and then probably again in Algebra 3 for those of you who took that route. Make sure that you have that parent function chart filled out. I will post my key sometime today. That way you can check what you have with what I have so that we're all on the same page. But those are the functions that come test time you need to remember in your head so you can do the transformations. And I'll talk more about that tomorrow when we're doing our notes. But I will post my answer key so that you can check yours with mine. We'll also talk about that last function, the greatest integer function, today in class. Okay, so don't panic about that. So tomorrow you need your pink sheets done and bring your calculators for a little bit of an activity. Okay. So what we're going to talk about today are some piecewise functions. Okay, so I'll first have you, where's my screen? Okay, a piecewise function is exactly how it sounds, okay? They're different pieces put together to be one function, okay? So what we have is a set of function where each covers a separate and specified part of the domain. I'll let you write that down and then I'll explain to you what that means. So basically what's happening is we're taking two or more functions and we're breaking the domain into pieces. So for example, this is one that we are going to graph. You'll see like this brace here that says, hey, these belong together. Okay. You'll have an equation and the domain piece that's specified. Another equation with its domains piece that is specified. Okay, this is the one time you're going to see not interval notation when we're talking about domains, okay, when we have a piecewise function. But all other times I will expect you to use interval notation. So what you'll notice is that if I were to take these two pieces of the domain, they would come together to be all real numbers. Right? This is x is less than or equal to 1. This is x is greater than 1. Squish them together. It covers all real numbers, but we just have two different pieces. Okay? So what I'm going to ask us to do is I'm going to ask us to graph this. Okay? How many of you recall seeing this in a previous class, like a function like this? No. You guys all have. Did you know that? Okay. Let's review then. Okay. What I'm going to ask that you do is that you just make a separate XY chart for each piece. So since this has two pieces, we're going to make two XY charts. Okay. And I can be color coordinated up here. So this first piece I'm going to do in blue. Okay. Where does the domain begin for this first piece? It begins at 1. It's x is less than or equal to 1. So it begins at 1 and it gets bigger or smaller? Smaller. X is less than or equal to 1. So we want to get smaller with the pieces of our domain. Also, do you notice how we have that equality with the x is less than or equal to 1? That means 1 is going to be included. We want to make sure we put a solid dot there. Okay? So now it's just a matter of plugging in. 2x plus 1, what does that look like if we had the full function? Excuse me. Y equals 2x plus 3. I'm sorry, 2x plus 3. What is that? It is a line. Okay? When we plug 1 in for x, 2x plus 3 would be? When we plug 0 in for x, when we plug negative 1 in for x. Okay? So we have 1, 1, 5, 0, 3, negative 1, 1, and that piece is going to go on forever in the negative direction because our domain is x is less than or equal to 1. So it's basically just a piece of that one. Now for our second piece, I'm going to go ahead and do it in red so you can just see the difference. This second piece, its domain begins where? It still begins at 1, but what's true about 1? It's not included. So what's going to happen is we're still going to plug in 1, but we're going to have to put an open circle at 1 since we don't have that inequality, since we don't have that equality, excuse me. And since it's x is greater than 1, we want to get larger with our x values. Negative x plus 4. Visualize what that is as a full graph. What kind of graph is it? Still a line, okay. So we're going to have a piece of a line. So when we plug in 1, what do we get out? 3. When we plug in 2, and when we plug in 3. So at 1, 3, we're going to put an open circle because 1 is not included in the domain. But then at 2, 2, and 3, 1, we're going to actually have coordinates there. Okay? The only time you're going to have the open circle is at the piece of the domain where you have that strict inequality. Okay, we've already talked about the domain. If we go from left to right, we have x values everywhere. Even at 1, because even though we have the open circle, the closed circle is above it, so we have x values everywhere. So our domain is all real numbers. What about our range? Okay, take about 30 seconds to discuss the range with you and your pod. What is the range? Talk about it. got it all together.
Oh,
wait, yeah.
Mary Kate, what was Pod 7's discussion?
We said that 5 is included, so it goes negative infinity, and then 5 in the bracket.
Okay, so it's everything 5 and below is what you're describing. So negative infinity to including 5, we have y values everywhere. What do you think about Pod 7's suggestion? Do you think it sounds pretty good? Okay. I'm going to give you a few minutes to, well, first of all, write this down. There are 3 pieces in this one. That's fine. Okay. What I want you to do is at your pod, start coming up with what this graph looks like. I'll probably give you about 5 minutes to, as a pod, work on this graph, and then we'll come together and see how you did. Okay? So as you're writing this down, I want you to visualize x plus 3. What would that look like by itself? X squared, what would that look like by itself? Negative x plus 2, what would that look by itself? Okay, so we have 3 pieces. This time they are not all linear. Some of them are. How many XY charts will you have if you use them? 3. You don't have to use an XY chart, but some of you really like that organization. And if you feel like you've never done this before, an XY chart can help you. Okay? But I won't require it. Okay? Work together, so I don't particularly want it silent in here. Okay. Yep, right there. Yeah, we are not exactly in the class. Like, so are you asking? What has started?
No, negative 2 is being eaten because it's bigger.
Yes.
The
So like
alligator
you
wants
know,
more
like
chicken.
draw the arrow and it keeps going forever, right? But that middle chunk, it starts and ends. So you're gonna hit a comma. Does that make sense?
Okay.
Parabolas are the
Can we give you one more minute?
yes, please. X plus 3. X is less than
Starting over. Okay.
This is the.
Yeah, just make sure that this, so this stops, like this one would be an arrow. Like it's just like.
Yeah, that's where I'm at.
X is less than or equal okay, I have a question. What if the lines intersect? That's at 1.
Yeah, but one's open.
I know, but I still have some open just
Yeah, one's up, one's one.
so if they're on the same
They just overlap. So since this is less than negative, that is smaller. Nope, that's getting smaller. Yeah, x is getting smaller. Negative 2 smaller, negative 3 smaller.
So that.
Yeah.
No.
So
Yeah.
whatever numbers are nice to plug in. I mean, you can plug in negative 5, but
I started at 1.
so you start at negative 0 and you stop at 1. Okay, so let's go ahead and talk about this graph. So this first piece begins at x is negative 2. When we plug in negative 2, we get 1. So we have an open circle there at 1. And then negative 3, 0, negative 4, negative 1, etc. There's your piece. Some of us were a little bit panicked at first about this. Okay, if there's more than 2 pieces, one of them has to start and end, right? So we start at negative 2. So you have negative 2, 4. You can plug in negative 1. You can plug in 0. But then you have to stop at 1. Okay? So you have an open circle at 1, 1. So we start at negative 2. We stop at 1. That should look like a piece of a parabola because it's x squared. And then some of you got a little nervous because when you started at 1 here, what happened? It's a closed circle, but it's at 1, 1, right? So I already have an open circle at 1, 1. Now I have a closed circle at 1, 1. It just fills it in. Okay? It just fills it in. An open circle and a closed circle, if they overlap, that's fine, because there's still only one point there. There would be our graph. All right. So real quick, domain. From left to right, we cover all the x values, so our domain is all real numbers. Do we have a question over here, Pod 1? You don't? Okay. Our range, this isn't very exciting. It's very similar to our last one, huh? We only have y values below which number? 4. So including 4 and below. So negative infinity to 4 would be our range. Okay, 4 and below. All right, you guys ready for our new graph? It's fun. Here's our new graph. What does it look like? Okay, so the notation looks like double absolute values. I like that. The graph looks like
Stairs.
stairs. Okay, so go ahead and draw it. I'll tell you here. What I want you to think about as you're drawing it, what's the pattern? Like, what do these double bars do to our x? If I plug in an x, what's the output? Okay? I want you to think about what the rule is. What makes it look like stairs? And don't feel like you need to draw like 10 stairs. As long as you have like 3 or 4, I think you get the gist. Right. Take like 30 seconds and talk about like any patterns that you see. Like if we plug in x, how does it determine where your point is? Like what is that double absolute value bar doing? I'll tell you what it's called here in a moment. But just talk about it.
One of them is included.
So I'm hearing a lot of conversation about closed circle and open circle and where those are. And every closed circle and open circle, they're kind of like below or above each other, right? I'm hearing a lot of that conversation. Okay, but it's a straight shot from one to the other. So every output is what kind of a number? Every y value is what kind of a number? Well, we have some negative y's down here. But there's like gaps. Every y, I'm going to change your word to integer because whole numbers don't include negatives. Okay? But your observation is good. All right? Every y value is an integer. Okay? Which is why we call it the greatest integer function. Okay? If my x value is 1.2, here's x as 1.2, I have a y value of 1. Okay? If my x value is 2.8, I have a y value of 2. If my x is 3.9, I have a y value of 3. What's happening? What?
It's rounding as absolute value.
Okay, which way are we rounding? we're rounding down. So if I have an x of 3.9, my y is 3. We're rounding down. So this is called the greatest integer function. Okay? Let me get my screen share here. I don't know why I don't have it. So what that double bar means is the greatest integer less than or equal to x. And it's exactly what Gabriel just described. We are rounding down. Okay? We can have negative outputs, so I would not call it an absolute value. So positive or negative, we're going to round down to the nearest integer. So we have the greatest integer less than or equal to x. Okay, so we're going to do 3 examples so we can get an idea of how this works. Okay, 3.4. If I'm looking for the greatest integer less than or equal to x, turn to your neighbor. What does that look like if I put in 3.4? Max, what do you got for it? 3. We round down to the nearest integer, so that would be 3. Even if this were 3.9999999, it would be 3. Okay. Negative 1.5. Talk to your neighbor about it. Okay, Aaliyah, right? Okay, I panicked if it was supposed to be Aaliyah. Okay, Aaliyah. Negative 1.5 inside the greatest integer function would output what? Okay, why negative 2? Okay, we have to go to the integer less than that number, and negative 2 is less than negative 1.5. Okay, so you gotta be very careful. If it's a negative number. Turn to your neighbor. Greatest integer of 2. Sydney, what do you think?
We said 2.
Greatest integer less than or equal to. If you have an integer, your output is the same. That's why we have those closed circles right there. Okay, there's the 0.22. Okay, so this is the last graph that you need for your pink sheet. Do not worry about the range for this function. Look at the range. It's 0, 1, 2, 3, 4, 5, and nothing in between. Do you see that? So don't worry about the range. The notation is too wonky. I will make you mess with it, but at least give me the domain. Okay, and then everything else that we need for that function. Okay. Your homework tonight. I mean, I'm really throwing it to you here. You have 4 required problems and 3 additional ones if you need it. Okay. What will you find on my website tonight? Okay, the answer key to your,